Hello, everyone.
Hey there. Do you recognize that guy? Once I get in focus, 1 second. There you go. Oh, someone's echoing headphones. So yeah, if you melt bismuth, who is that? Is that? I think it's Sebastian. I think you're listening to two streams. Oh, maybe it's Steve.
I would just mute myself, but I think it's Steve.
It's Steve. Okay. Okay, so that'll sort itself out in a sec. Yeah. Okay, super. Hello, patrons. Oh, is it? It's actually me. I'm an idiot. Okay, right. Okay, so just to show that I am actually here. Hi guys. And down here, so that's the bismuth crystal we were just looking at. And so one of the cool things about bismuth is the actual solid float in the liquid, which is rare. So when you actually make these crystals, you melt the metal, and it looks kind of like mercury, and the crystals sort of form on the surface and they float there like little icebergs. So you get these really cool angular crystals. But that's not all I've got. So I've got the microscope on the other camera. So let's see what we can do here. Super. So here we have the trilobites again. This is actually the live view of the trilobites. These really awesome eyes of theirs. But that's not all. So actually, encouraged by that, I actually went looking for other trilobites, and you can get some really cool trilobites. See if we can get this guy in there. It needs to go up a bit. This guy really just needs to be seen to be believed in that. That's his mouth. And then he's got these. So this guy's also got the awesome eyes on him. I actually get it. There we go. Can everyone hear this? Everyone's muted. Ah, good. I was just really creeped out for a second there. I was wondering, did I actually like kill all the audio or something? So not only is he super spiky, this guy, so he's got these extra spikes on him, but the mouth is the thing that's just really super weird. Let me just see if I can actually freestand that. So no one's actually sure what these things were actually for, but they reckon it might have been, you know, they were like the rhinoceros horns on the beetles, that they would actually use them to compete with each other or something. But no one really knows. And this is another Moroccan trilobite, this guy. But the other one, I've not really even got out yet. But the thing that's awesome about him is very simple. Let's see if we can get him in there. Where are you? Oh, there we go. That is a trilobite eye on the end of a stalk. I'm not sure which one I'm looking at. That one probably. So that's the trilobite head at the bottom there, and I'm not quite sure what the hell these guys were. They were probably all buried in the mud or something. But the amazing thing is, all the trilobites have this sort of 180-degree eye sort of arrangement. All the axes get messed up on this. There we go. Beautiful. So let's actually zoom this guy. So we should, if there's any justice, I'll zoom right in on that. There you go. One stalk trilobite eye. But you see what I mean? There's this sort of, they're all 180-degree, the trilobite eyes. They wrap right around, and virtually all of them have this sort of flat top, which is weird. I mean, you'd have thought, well, why wouldn't you have eyes looking upwards as well? If you're going to have eyes that essentially give you 180-degree vision, why not point them up as well? Yeah, if you actually take a look at, say for instance, these Moroccan guys, it's fairly clear that super. It's fairly. You see what I mean? They don't have any eyes on top. It's just weird. One sec. Let me see if I can focus that for you. Right on the limit. Yeah. So yeah, I just thought they were kind of interesting, so I'd show them to you. So let me go back to the regular camera. There we go. Hey guys. So does anyone have any questions, or?
I want to listen.
Just want to listen. In which case,
at first,
let me see. Right, this one, I'm not so sure I can get this to work. We'll see. This one's a little twitchier, but so you all know superconductors levitate above magnets, yeah?
Yeah.
But yeah, I can't do anything useful with them because you need really cold temperatures, right? So let me show you my magnets.
Neodymium magnets.
Neodymium magnets. So I think I need to go down a bit. And with any luck, there we go, magnets. Oh, wrong way. Let's go as wide as we can. There we go. Super. So there we have some magnets, and they're 25 of them in a square arrangement. Let me get them out a bit more. So I think means I can get a focus. Good. Now, that looks like it's just a. Oh, there you go. Super. There you go. Hey, got it. Super. That was a bit of luck.
There's your hoverboard.
There's your hoverboard, and it requires no magnets
and no copper.
No copper. But the one thing I notice is it sort of curiously likes to hover over there. There's only one other place that's stable. It's the problem is that it's not quite level. I've not got in a level table, so it keeps running off. But that, there you go, diamond formation is stable as well. Fortunately, all. So
where did you get these magnets in this configuration?
So it's pyrophoric graphite used by off eBay, and the reason it hovers is because of something called diamagnetism. But you need the really powerful magnets, and almost the only thing you get to hover is these little pieces of whatever. But yeah, it is actually really cool that, you know, no power required, and it just sort of sits there and hovers.
And you have a piece of neutron moderator.
Very much, yeah. Actually, that's quite cool. I like that.
It's
That
nice.
shows up, right? So this is one of the problems. Is I was trying to film this with a regular camera earlier, and it just wasn't happening because it's only hovering about half a millimeter. Oops. It's only about half a millimeter above the
Surface.
magnets, so it's actually quite difficult to. There we go. Oh, that's beautiful. Yeah.
Where did you get these magnets from in this config?
You just buy them off eBay. They're about, I don't know, $15 or something.
Yeah.
But if you do, I think it's pyrolytic graphite you look for, and quite often they'll sell the magnets at the same time because you need them in the right arrangement. If they're not in, let me go back to regular. Yeah, you actually need them in a square. In fact, let me show you. Let me show you what it looks like in real life. There you go. That's the magnets, and these things are really strong. You actually, just drop these things and let them fall on the thread. They'll shatter, right? So you just need
quite brittle.
Yeah. And I took this into work just to sort of show some of the guys, and they'd never dealt with the magnets before, and they weren't paying attention, and boom, it was all busted up. So,
that's the stuff they use in windmills, right?
Yeah, absolutely. This is the revolution of. This was worth a lot of efficiency in terms of electrical generation.
Yeah. Because I do know that the technology to make those it's exclusively in China, because it used to be developed in the US, MagnaQuench, and the Chinese bought them, and within 10 years everything went from the US to Inner Mongolia, where they have these big ass rare earth magnet mines.
That's the thing about China is it's hugely mineral rich. Which is an irony. You take a look at the islands like Japan, which did quite well on technology for a bit, and England, which did quite well on technology for a bit, and they're both incredibly resource poor. Which is maybe not unsurprising. It's a tiny country. What are the chances of you having everything you need there? In fact, one of the reasons England did so well in the early on with the Victorian age is it had coal and it had iron ore, which is basically all you needed for Victorian age technology. But once you get on to things like we need neodymium, no, or uranium, you just don't find these things in England.
You brought home from you some sand from the beaches from the US, right?
Correct. Yeah.
That's monazite sand.
Correct. Yeah.
That's got neodymium in it as well.
I was actually after the thorium, but it's in fact I think it's
about 1/5 is thorium.
Yeah, but that's crazy magnetic as well. You surpass. Easiest way to just separate it out of the sand is you just get one of these super strong magnets and just run it around, and the magnet just comes back as a big ball of fur on it. All the white sand drops away and you're just left with this big ball of fur.
Right.
That being said, the stuff that I found was very magnetic and not very rich. You had to really look around to find the radioactive stuff.
Yeah, because it's also bastnasite. Bastnasite is also, it also has neodymium, but it has less thorium. So that's the thing about monazite. You cannot mine it because it has thorium in it, and thorium is considered a source material in the US. And source material is something which you can use for nuclear proliferation or creating nuclear power, which makes them nervous.
It should. In fact, this is people keep asking me, what about thorium reactors? And I think the answer is, it's technically challenging to do, right? And the fact is that they developed all of the infrastructure for uranium for the obvious reason that
that's true.
It breeds bombs. But in principle, you can do it all for thorium if you're willing to put the money in. But you know, the downside is any technology that produces neutrons you can use to make bombs.
That's it. That's it. You can even use a spallation source if you want to.
But I mean, with thorium, the stuff is, well, even with uranium, it's dirt cheap. I mean,
yeah, thorium, you just need to dig up a cubic meter of crustal earth, and you have like I believe 20 grams of it. So it's everywhere.
well, if I remember rightly, you know, it's like 50. If you could buy it, the commercial traded value of things like uranium is only $50 per kilo or something.
Yeah.
And yeah, the 238 of breeding material. You just, if it captures a neutron, you get plutonium. So
the 238, you mean?
238, yeah. All you need after that's the neutrons. Now, neutrons are not easy to come by. I mean, you're right. You can get them by spallation source or reactor. But yeah, I mean, that was always one of the things that made me rather nervous about the thorium. Is the reason everyone goes for uranium, of course, is.
Well, the only reason why you wouldn't go for uranium if you don't want to get as much transuranic waste, but but that's basically it, because the proliferation argument is moot, because uranium-233 is an excellent fissile material. You can make bombs out of that as well if you want to, but you have some uranium-232 issues there, and uranium-232 is a high gamma emitter, so it sends out, look, I'm here. Everybody went where it is. Whereas plutonium is easier.
Yeah, and it's an alpha emitter, so no one, you almost just put it in your hand baggage.
It's not that hot.
Yeah.
By the way, Thunderfoot, I had an interesting discussion with my brother a few weeks ago, and the discussion was if North Korea has an atomic bomb, and they decided not to deliver it with a rocket because they would not be able to hit anything, but instead with a ship, and the ship would leave North Korea, would be under intermediate satellite surveillance, of course, by the entire world, so they could not transfer the bomb on the high sea to another ship, so they would have to smuggle it, and there are only few companies in the world where a North Korean ship may dock. One of them is China. And the Chinese, of course, are not interested in getting the Black Peter or being blamed for the nuclear attack later. So I guess they have very effective controls in place in detecting a nuclear bomb on board a North Korean ship. So my stance on this thing was it's absolutely impossible to bring a bomb aboard a North Korean ship in any harbor of the world, because the harbors know that threats like this exist. They know that nuclear proliferation is a problem, and because the detectors are so sensible that they would basically sniff it out immediately if a ship was carrying a load. And his stance would be, no, you just cover it very deep, put it in a lot of sealed containers, and it is probably to go into an harbor undetected. What's your stance on it?
My reckoning is with things like plutonium and uranium, they're alpha emitters. They put on some gammas as well, but they're relatively easy to screen.
Just put some lead around it.
Yeah. Or water. Yeah, anything. I mean, and my reckoning is your chances of detecting it, or you just stick it underneath the ship, your chances of detecting it are basically zero. I mean,
okay.
Just drag it.
Yeah, I mean, if you got like you were saying, if you got a gamma emitter, then you're a strong gamma emitter.
Yeah.
Then it becomes a lot trickier, because I mean, the thing that sort of screams out on these things is with all the gamma ray detectors, you measure the energy, so you know the nuclei that it came from. So if it's a hot gamma, very difficult to avoid detection. But if they're just alpha emitters like 235 or plutonium, you can have one in the same room as you, and it's actually quite difficult to detect. Well, actually, let me rephrase that slightly. With the I've got some reasonable gamma ray spectrometers, and with that, you've got to sort of sit there and count for a long time to find some of these things.
Aren't there any daughter products? You know, either from
Well, there will be. I mean, all of the daughter products usually give off X-rays.
like
Actually,
iodine.
yeah.
Yeah.
But I mean, if the stuff is freshly processed, you know, how many of those are you going to have?
Not a lot.
I mean, you're right. They're going to have
disintegration.
They rot away. They rot away.
Yeah.
So
easier to detect than drugs, probably, but harder than.
But the dogs can sniff out the drugs. I'm not so sure. I trust your dogs on nukes.
Not if they are under the ship.
Under the ship. That's true. Although, from what I can tell, the last I heard is that, yeah, for the drug smuggling to America, they'd sort of settle on these like high-powered boats, which basically no one could catch.
Miami Vice style.
Yeah, that's that sort of thing. You know, they're. I mean, presuming if you got a drone or something, then it's no problem. But
I think they busted a submarine construction facility in Colombia or one of the other companies, and I don't know if this was in the news or someone told me the story that European engineers were also helping them constructing submarines for the drug smuggling business.
Yeah. I wouldn't. Submarines are kind of metal coffins.
Yeah.
You know, anything goes wrong with them, and
yeah, that's what they did. They drove very close to the surface. They had the turret sticking out, and when the Coast Guard spotted them and came near, they just scuttled them. And this good stuff is big on the American West Coast. If you're like 10 kilometers away from the coast, the bottom of the ocean is already 7 kilometers, also 8 kilometers deep.
Yeah.
And then you just scuttle it, and they can't even gather the evidence. Then all they have against them is maybe that they tried to get into the country illegally. And
so we're talking remote controlled submarines here. There aren't like people
manned submarines.
Oh, right. So they actually scuttle them with one of other people.
No, the people driving them would scuttle them. So they're not so big. Submarines, maybe a ton or two of cocaine they can load, and maybe 2 or 3 people crew. And so when they see Coast Guard, the crew gets out, and the last one pulls the plug.
Not to mention that they are death traps for journalists.
Yeah, that was also a story. Yes.
Didn't you hear, Phil?
No, I missed this one.
There was a Norwegian guy or a Danish guy, I don't know, and he built his own submarine, and he took with him a journalist, a woman, and she was interested, you know, and he killed her, and they found bits of her bag.
Yeah. What?
Yeah,
he killed her, and then he scuttled the submarine to vanish the traces. And counted on that they would never find the submarine and never be able to retrieve it.
She was stabbed 15 times.
Yeah. So the first story, he told everyone that there was an emergency, an accident, and he luckily got out and she didn't.
Yeah.
And then when they found the submarine, then he had to piece by piece revise the story. And she also had here comes the sad part, and I hope there are no children around. She had genital mutilations, and right now he says he inflicted them on her after he killed her. But this is very hard to prove after a few days in seawater. So it's quite a gruesome story. So a real pervert, basically. And then when he was out on the ocean on the submarine, he did some nasty stuff and then scuttled the submarine. Really horrible story. Was it Sweden, Denmark, Norway? One of the Nordic.
It was a Danish submarine, and the journalist was called Kim Wall.
Yeah.
Actually, that's pretty horrific. I mean, they'd be trapped in a submarine with someone who's nuts.
Who knew we would get here this fast?
Yeah. But yeah, that's submarines are expensive. Though. I mean, was he rich or something?
Yeah,
I think he put a decade of work into it or something. So he really put a lot of effort into building the submarine.
That's weird. And then, I mean, you can get all sorts of weird psychosis things if you get the pressures wrong in those things.
Yeah, he was the CEO of RML Space Lab apps, so he probably had some money lying around. So,
but I mean, the thing is that you can go crazy in those things, but I'm not so sure it makes you into a sexual predator. You know, I mean,
that was a predisposition.
I think you have to be crazy actually to get into one of those things the first time.
I know you have to, so it really is. You have to suck everything in just to get in.
Yeah. Have you been in a submarine, Phil? Any of you? In a real submarine?
I have.
No.
In Saint-Nazaire in France, there's a German U-boat. Yeah. With a French submarine in them. So it's a museum submarine.
Because we have in Bavaria, we have the Bavaria Film Studio, where they produced a little bit of Das Boot, of this very famous movie.
That is probably one of the greatest war films ever.
Yeah. And they have a life-size model, or I think it's even an original. I don't know.
It's a quarter size. The one they used for the filming at sea was a quarter size, I think.
No, certain sections are like life size, so you go into there and you have it like it would be on a real submarine. It's a one by one reproduction, because they filmed inside a submarine, and so some parts on the set are like a real submarine, and you can visit and go there. I can really recommend.
Yes, I mean, for certainly the film set, absolutely, it has to be 1-to-1 because.
Yeah, and it's in an iron hull. So you climb up a ladder. From the outside, it looks like a submarine, and you go in there, and you can bump your head because everything is tiny. This is the biggest thing where I don't know how they in Das Boot did not have like open wounds on their heads all the time, because bumping the head is so super easy in there, and everything is sharp and edgy and hard and metal, brutal, absolutely brutal.
Submariners are selected by size.
Yeah.
They only put small people in there.
Yeah, I think I'm at my 1.92 m would not qualify as a candidate. Same goes for tankists also.
Das Boot was unquestionably just a superb film from start to finish. You know, this sort of. They all go out and they're all nicely shaved and. And then you get these sort of weeks of boredom, just sort of sitting around waiting for something to happen. Then something happens, and they almost all die. And
by the way, I loved your Dr. Dolittle.
The Dolittle raid.
Absolutely, that was awesome. There was a film, wasn't there, with Ben Affleck? No, no.
Pearl Harbor.
Yeah,
I only know that because I read it in the comments and for some reason someone was saying it almost ended his career or something, although I'm not quite sure why.
This film made me a little bit angry, I must say.
What, Pearl Harbor?
Yeah.
I've not actually seen the film, so.
You have seen it?
I've not.
You have not. Okay,
I've seen Das Boot several times.
Okay,
but I've never seen Pearl Harbor.
I think I can't spoil it, just the way you can't spoil Titanic. So
yeah. But I've been told that it takes so many liberties with history.
Yeah,
and it's fan fiction history rather than.
Yeah. And it was true for the Doolittle raid that they dropped the bombs basically in an industrial area and mainly hit like military production or industrial production.
They tried.
But later on, basically they bombed civilians indiscriminately.
That was Robert S. McNamara and Curtis LeMay. They firebombed roughly, I think, 4 or 5 million people in the end.
And so when during the movie they repeat again and again, and please remember, only hit military targets, only hit. I think this phrase comes like up 3 times, and then I say, no, Americans, you might be right on this occasion, but don't stress your chivalry and things too much, because in the end you just put every city ablaze that you could. And I think the atomic bomb attacks were not even the one that caused the most victims. I think it was a
Tokyo.
Fire attack on Tokyo. Yeah, that cost like hundreds of thousands in like 2 nights.
Can you imagine? Yeah. I mean, they had these big B-52s, and these things flew like how much? Yeah, no,
B-29s.
no, but after that, when they started firebombing Japan, they didn't do it with those small ones. They used the B-52s and B-51s.
25.
B-29 Super Fortress is the one that they used for
Yeah.
the fire bombings.
Yeah,
10 tons of bombs a pop.
yeah, and but those could fly at 16,000 feet, and they took them down to 5 or 6,000 feet because the accuracy was so bad on those high altitudes that and LeMay, he only focused on target destruction, and while they were so inaccurate, the target destruction was too low, so he took them down. And
So that was the discovery of the jet stream.
yeah, really.
Yeah, they didn't know about the jet stream, and they used to, all their first bombing raids, all the bombs went somewhere else, and it's like, okay.
How the hell did that happen?
And later on, they sort of worked out that if they sort of took a load of stuff off the planes, they could fly them faster, which meant that the Japanese planes couldn't intercept them, and they flew high enough to avoid the flak. But it's one of these very brave things that, from the calculations, it works on paper. We fly above the flak and fast enough to avoid the fighters, but we have to strip all the guns out of the plane. Well, half the guns out of the planes to do it.
Yeah.
But it worked, and they were basically unopposed bombing over Japan.
Yeah, I was in Aomori once. This is a city in the north of Japan, very north of the main island of Japan, right next to the one that comes on top where the skiing takes place and the population is not so dense. And there was some memorial about a bombing run, and they put fire to Aomori, and 30,000 people died. And this is a comparable number because this is often the number cited for the Dresden bombing run. Where they also firebombed Dresden, and also around 30,000 people died. The difference is in Europe, houses are made of brick and stone, and in Japan, houses are made of wood and paper. And wood and paper is much more prone to catch fire and to spread the fire. So the Dresden run was like 1,100 bombers, and they lost about 100. And the Aomori run was 16 planes, 16 planes, and they didn't lose a single one. So the Japanese air defense at that point was so crippled that they could not even stop 16 planes. And because of the paper and the hot weather and the strong wind, those 16 planes killed the same amount of people that 1,000 bombers managed to kill in Dresden. And so incredible easy to kill Japanese with firestorms, and didn't stop them. Did it anyways.
Isn't the Dresden bombings considered officially a war crime? Because they used phosphorus in those bombings, or was it?
Officially would mean that there was a trial, something, and someone got convicted, and nothing like this happened for any Allied soldier in the Second World War.
No, that's true.
But the British are really ashamed, and a lot of people involved in strategic bombing got medals after the war, but the Bomber Harris didn't, and they removed statues, I think, by now, and renamed things named after him. So Bomber Harris is no longer in good memory with the British, and I think that's fair.
Yeah, I mean, with hindsight, the thing with Dresden is it didn't really achieve anything. It was just basically destroying a city because you could. But let me also add one other thing about Dresden. Is one of the reasons it killed so many people is the Russians were fairly close, and the main weapon that they used to stop the Russian armor was a gun called the 88 Flak, which was also the prime anti-aircraft weapon. So basically, because the Russians were nearby, they'd stripped all the air defenses from the city to try and stop the Russian armor. So that's one of the reasons why there was so if people are shooting at you, it screws up your bombing accuracy.
It was typical, isn't it, that because the 88, that was an accident as well, because they didn't intend to use it as an anti-tank gun, but it turned out to shoot them like,
it was I forget what it was. It was Arras or something. The Germans they hadn't quite broken through to the coast in in France.
Yeah, Arras.
And,
That's true.
and there was some of these British Matilda tanks, and none of the German guns could stop them. And out of desperation, they used the 88 flaks, which
Yeah,
did stop them.
Something like that should
But
have.
the thing is that rattled the Germans sufficiently much that
the story how when they started doing it systematically was when Rommel in North Africa needed anti-tank equipment, and at that time they couldn't really ship him anti-tank equipment because the Italians were so bad in holding the Mediterranean Sea, and so they had to improvise. And so for Rommel, they improvised and converted a lot of the flaks to anti-tank guns. And then they found out, oh, this is really working very well. And then after this, I think that the entire army took over and more systematically used this improvisation wherever they could and whenever they needed it.
I've seen pictures of American tanks that got hit by the 88. And it's like you shoot a tin can with a 50 BMG.
Yeah, I think it penetrates at 2.5 kilometers or something crazy like that. So the normal Sherman tank, if an 88 opens up at 2.5 kilometers, it penetrates. And I think that the Sherman would not penetrate the front skirt of the flak gun at that distance. So basically, the people, if they were standing good, they were impervious to return fire.
And every Sherman that got hit caught fire.
Yeah, that's not quite true. The Sherman caught fire very often, but a lot of the crews got out. So the Sherman was quite a deadly thing for their own people, but not as 100% as it's often portrayed.
Yeah,
right. But the thing about the 88 is they put it in the Tiger tank, which
it's the same gun. Yeah, it's the same gun.
But those, head nose to nose, it was. I'm not even so sure the Sherman could shoot them at point blank range on the front. Yeah, from the back they could do it, or from the sides. But there are actually interviews with people I've seen who basically the Tiger came right across in front of them and they sort of shot 3 rounds into it at point blank range, and all it did was turn its turret around. And,
you often had a soft kill. You did not blow it up basically, but to disable it.
Blow tracks off or something.
Blow the tracks off, or shake the tower so hard that it will not turn anymore, or hit the gun so that the gun elevation would not work anymore, something like this. So the chance that you get a soft kill is very, very high, because in the end it is a 75mm gun, and it has a very
heavy,
very high velocity at point blank range. So it will take damage. Yeah.
What was the name of the tank ace? Whitman.
Right? Yeah. But Germany had a few. He was the most famous one because the propaganda built him up the most.
Yeah, right.
But Germany had quite a few.
The thing that made him so good as a tank commander was that he got used to the Sturmgeschütz.
Sturmgeschütz.
And as a tank commander, he exited the tank and looked into his surroundings, and he tried to gauge how his enemies could approach him and such. And it seems that he even didn't use the turret traverse of the Tiger tank that much. He used the tank as a whole. So he used the tank.
He used it like the gun carriage,
Yeah, and that meant that he was less vulnerable because he was always facing his enemies from the front.
Yeah, the Tiger would be at a slight angle, I think 15 degrees or so.
Yeah.
As far as I know, the armor of the tanks back then from Germany were hardened in one piece. They heated them until they glow red hot, and then they cooled them down to harden the whole armor.
Quench them in oil. That makes the metal more stronger because it captures the carbon atoms from the oil after it has expanded, and then it contracts again.
Yeah, but this varied. The process of hardening the army, it varied. There's a famous report, I think the Russians made it public years ago, not early before that, where they compared a Tiger tank and a Königstiger tank. And the way they compared it, they let a T-34-85 shoot it from like 400 meters. and then they found out that the armor on the Königstiger was at certain places about twice as heavy compared to the Tiger. Yeah, no, twice as heavy compared to the Tiger.
Oh, heavy.
Yeah, but the shots went through, or the spalling was happening so hard because the quality of the steel of the Königstiger was so bad compared to the Tiger, because late war production did not allow to produce any high quality goods. So basically, the idea was good, and they carried a lot around like 60 tons of weight and 30 tons of armor or something like this. But because the quality of the material was so bad in the end, the effective protection on the Tigers and Panthers was in certain areas superior to the Königstiger. And you could not think that if you look at photos of both of them, because the Königstiger looks like an indestructible ball of metal.
Yeah, and it has sloped armor at 45 degrees. So,
but details matter, and if you have no longer the resources, and the producers know that their tanks are no longer going into battle because there will be no fuel, they just meet the production numbers, push the stuff out, and don't really care. If I produce a Königstiger in the spring of 45, then I say, okay, let's get it out of the factory as soon as possible so that we don't get bombed and we don't care about the quality at all. Yeah.
And they didn't have the correct alloys to make reliable drivetrains.
Not enough chromium anymore. So
drivetrains would break after 500 kilometers of operational use or something like that.
500.
So well, on the train,
500 is really, really ambitious.
On the train.
When they used the Panthers the first time, they were also all 6 a complete loss. And none of them because of enemy interference, all of them because of mechanical breakdown.
Yeah, Thunderfoot, you did the video with the tanks once, and you had the Ferdinand. Can you remember the elephant?
Oh, that thing. Yeah, the elephant. Yeah,
the elephant. The elephant is one of the few tanks. There were only 39 produced, and none of them were destroyed. They were all abandoned. They were indestructible. You couldn't destroy them. So as long as it was operational, you better not get in front of it.
Yeah, but after that was the one without a machine gun, right?
Yeah, correct. That one. And after it fired 10 times, it broke down and it was abandoned.
So it was too heavy for its drivetrain, and you're right, it had no close infantry defense, so it wasn't separated from the infantry. All you basically had to do was Molotov cocktail on the air intake, stops the air getting into the engine. Tank's dead. I mean, and tank recovery of something. It was basically the heaviest thing on the battlefield. The only thing that could really move it was 2 other tanks.
Yeah, the Bagatine. To salvage a Tiger, you needed a Tiger.
and really 2, because otherwise you were trying to pull the weight of 2 Tigers with 1.
Yeah, and also to salvage a Tiger, you need probably air superiority, because the other side knows that they achieved the mobility kill, and then they will try to get an air mission on the way to knock out that salvageable wreck as soon as possible.
Yeah.
By the way, did someone get the notice about German tanks blowing up in Syria?
No.
So the Turkish are using German Leopard tanks, Leopard 2 tanks.
That's
Leopard
true.
2A4, and Kurdish forces had a big battle a few months ago with Turkish army and blew up 10 German Leopard 2A4 tanks.
With what?
Yeah.
With a various amount of weapons, not with German Milan ATGM, because that would have been too ironic.
RPGs or
something. But with all other means. So a few with the usual IED type of warfare, but I think 5 or 6 were blown up by Russian or Iranian-made ATGM. So the Iranian Tufan or one of the Russian models. They have so many different names that I don't really. I think it's not really known what they used. Yeah.
Yeah, I mean, that's the problem now, is the infantry have, if you run into the wrong sort of infantry, a tank, everyone knows where you are in a tank.
Yeah. And there are videos on YouTube about these incidents. and the Turkish army was not really very smart. Basically, the area they used them is quite suitable for tanks. So a slight hilly terrain where you can find cover and move around and do ambushes and all sorts of stuff. So you can work with tanks very effectively there from the terrain. And I think that's what the general staff of Turkey thought when they issued the order to use them. But then on the operational level, the people commanding them did not use them very wise and did not have infantry. So basically what you see is them standing around in the open for like minutes, 10 minutes, 20 minutes. And this is enough.
Suicide.
If you encounter in the Syrian, or not Syrian, Kurdish forces that fight Syrian tanks and ISIS tanks and ISIS vehicles of all kinds.
T-72s.
Yeah, they have experience. They know how to lead a vehicle destruction squad up to a good firing position, set up and fire in half an hour. They don't need more time. And so that's what they did. And this knocked out the Leopards. Yeah.
How much they must? Well, they like. I think the Abrams are like 20 million a shot. Or how much are the Leopards? They're probably comparable. They're like 10 million a shot or something.
I think that's the amount. And now Turkey is asking Germany to provide the upgrade package with better armor protection.
Is it the 2A5 or is it the 2A6 already?
I don't think we will sell them the 2A6, but they want basically what we have currently now. A6 is the 2A5 plus or something that we have in our use, but they won't get it. It does not look like they will get any. Not as long as there is an active war going on there.
So I've not been keeping up with Syria.
Yeah, it's absolutely chaos at the moment.
I mean, because it is dragged on for what, 3 years now?
Yeah, but it's not the same war. Basically, this is, I think that now it's going into like the third stage, fourth stage, where again.
So what happened was after the Arab Spring, which spread from basically the entire northern African continent, Syria was in a vacuum basically, and from this vacuum all these separate forces emerged. So it's not just ISIS, but it was also rebels, people who wanted to fight against Assad, and one big mess really. It's everybody is fighting everyone in Syria at this moment.
And currently you have like two flashpoints. The first flashpoint is east of Damascus, where there is still a big pocket of Sunni resistance against Assad. So basically several Sunnite rebel fighters that are against Assad, and they control swaths of countryside and city side with quite a lot of population. So the rebels talk about 400,000 people trapped by Assad, and Assad is like bombing civilians now. There is footage on YouTube where you see artillery and cluster bombs dropped on urban residential area. So this is really horrible what's going on there. And he did this before when he the second biggest city of Syria, when he took it back.
Aleppo.
Yeah, exactly. And there he was very successful with the strategy. I think the general who is doing this is the same guy who also took back Aleppo. So basically bombed them into oblivion for 3 months and then let them evacuate and filter out and arrest the young men on the evacuation trails. Basically, this is the idea. And the second flashpoint is Afrin in the north. It's a city controlled by the Kurds, still controlled by the Kurds, and also there are American special forces embedded together with the Kurdish fighters. And for this reason, right now, the Turkish forces who want to advance and take control of that city do not advance anymore. They are stuck. And on the other side, the Kurds invited Assad forces into the city because they think if there is some Syrian army in the city, then the Turkish would also be a little bit more cautious in advancing anymore, hesitant in advancing anymore. So this is the second thing. And there was a really, really good CNN piece, I think 4 weeks ago, where there was an American 3-star general interviewed in Syria on the front line. And everyone would be wondering, what is a 3-star doing there in Syria on the front line? And basically the only reason why he was there is because to protect the his own forces and to de-escalate the situation, because when the Turks know that there is an American 3-star in the area, they will not use air force, they will not use artillery, and they will also not do a direct attack. So right now it's very schizophrenic. The Israeli took out 50% of the Syrian anti-air 2 weeks ago at the loss of one own plane, because they don't want the Syrian to have a powerful strategic anti-air system, and also not that the Hezbollah gets armed up with too many medium-range ballistic missiles. And this is fucked up. The Russians only want to make America look weak and preserve their foothold, like the harbor, the warm water harbor in the Mediterranean. And I don't really see where this is going.
That's what gets me, is I don't see how this is going to end. I mean, it seems to be more or less just a stalemate of sort of shooting at each other on the ground. It's all World War I stuff. There's no obvious end in sight.
And it's almost a world war. If you see the parties that are involved, France is threatening Assad. If he uses chemical weapons again, then France will also intervene. This is something Macron said like 3 weeks ago. Germany is delivering arms to the Kurdish forces. America is involved. Russia is involved. I think if China is involved, then we could speak of a world war. They are the only ones that are still not involved. Yeah.
Even the Dutch are involved. We have 5 F-16 dropping bombs. It's
on the IS, so they are from Iraq bases, or
from Jordan.
From Jordan. Okay.
From Jordan.
And this is the next thing. A lot of NATO is now launching from Jordan, because they do not longer trust the NATO base at Incirlik in Turkey, because Turkey is also, and this is something new, or not really new, is also increasing their stress with Greece. So the border incidents between Turkey and Greece have also increased, and I follow some of those forensic and observation guys on Twitter. I can link a few accounts if you like later. They observed that Greek littoral ships that are for Coast Guard and such have armed up and put sandbags and machine guns in certain areas on the ship to be better prepared for a low-level skirmish with Turkish vessels in the Mediterranean. So absolutely crazy what's going on there.
And in the meanwhile, the Turkish have our Patriot missiles. So I live down in the south of the Netherlands, and there's a NATO headquarters just 10 kilometers from here, and it used to be protected by Patriot missiles. You know the Patriot missile system, right?
Yeah. Container.
Yeah, and they are all positioned in southern Turkey at this moment.
Okay, because some German anti-missile defense was there, and we retreated them because so you are the guys who took their place. Okay,
it's ridiculous.
Good to know. Yeah.
So Thunderfoot, I just used your solvated electron footage as background for my own video.
Oh, excellent.
Are you planning on making new ones? Because I really want to see new ones.
So that's actually ongoing research, the solvated electron in water, because it was a really hot topic about, 30 years ago or something. And then everyone kind of lost interest in it. And it does all sorts of weird stuff that there's no real good explanation for. So I'll see if I can find it. There's we had one of these. It looks like a Christmas tree. Did you see the one that looks like a Christmas tree?
I only saw a ball-like and one.
Let me see if I can. So we actually had it made into a Christmas video for the institute where I work.
Oh, really?
Yeah. Just give me 1 second.
I'm building a vacuum chamber now for the experiment with the where I discharge my cap bank through a wire of lithium in a vacuum to see if I can capture the
color
color
of
of.
lithium gas.
Yeah.
I would really be. I'm really interested in that.
That's the cool stuff.
I got a hole here and a hole here, and they are for the.
Oh wow! Let's take a look at that again. Sorry, I was on another window. Let's take a look at the box.
Yeah, and keep talking when you show it, so that you stay in focus.
Here is a hole, and here is a hole, and I got M10 screws where I drilled a hole in the wait. I have them in my backpack. Where's my backpack? Oh, I think I don't have it up here right now. It's hexagonal, the head, and I drilled a hole. I'm planning to make threads in it, and then I can make. I need a way to get voltage inside there, and to seal the intake. So I took M10 screws, so they fit in here, and O-ring, so I can put the screw in here, put a nut from inside, and this should press the screw tightly in there. And to connect the cap bank, I can screw in the I can screw another screw in the hole that I drilled in the head of the M10 screw. So I have power inside of this vacuum chamber. And with the O-ring, it should be airtight. Because when there's vacuum inside there, the screw should be pressed even tighter in the O-ring. But it's not quite finished yet. I have to find a way to get the to connect the tube from the vacuum pump here in the top.
It depends what sort of vacuum you're after. With something like that, you're probably up for what, millibar type stuff? Thousandth of an atmosphere.
Wait a second. I got my vacuum pump here, and it goes down to 0.05 Pascal.
That's a very high vacuum. You'd be doing very well to get that actually. Stuff starts degassing
and before pumping it down, I will flood the chamber with argon gas.
So you might actually be better off actually having a partial pressure of argon in there anyway, because otherwise what you'll have is as you heat the stuff, it just evaporates off. And whereas if you actually have some argon there, it sort of keeps it more local.
Okay.
Maybe.
Yeah. Never. I didn't see someone try this before, so yeah.
Yeah, I think you'll actually be better off because otherwise all that's going to happen, unless you've got a really good vacuum, is the stuff will diffuse out really well. It just moves out in straight lines very quickly into a vacuum, the molecules, and so the nuclei of lithium. And yeah, they dilute very quickly. Whereas if you have a partial pressure of gas in there, then their mean free path is much shorter. So you actually keep it much more localized. you might be better off just filling it with argon, actually. I think about it.
Okay. Yeah. Then I have to do a second tube up there.
In fact, you inspired me now. I'm tempted just to get a tube, fill it up with argon, and try and vaporize some sodium or potassium in there. So let's start with something easy here, you know.
I have my cap bank there. I got 3 more of the capacitors. With at full charge, they pack 4 kilojoules of electrical energy.
Okay, and what discharge rate you're looking at?
Ooh, they discharge really quickly.
Yeah, you're essentially passing through a metal. I mean, the only thing that's going to save you here is that as the metal gets hot, its resistance goes up, so you don't pass as much current. But it'll vaporize. It'll vaporize.
I tried with 1 capacitor and 0.2 millimeter copper wire, a piece this long.
Yeah.
I discharged the capacitor. Okay, I charged it to 60 kilovolts and discharged it through the wire. And well, after the discharge, the wire was gone.
Yeah.
And a big cloud of smoke rose up to the ceiling.
But what the hell happens to the copper atoms at that moment?
They'll react with the air at that temperature, especially if they're gas. You'll get copper
it's
oxide
simply
out.
a kind of burning reaction, right?
Just burning, yeah.
Burning the copper.
But
not all the copper will burn. I mean, the same thing happens when you blow up a circuit board. You end up sputtering copper all over everything.
Yeah. I read a piece about some guys in the Technical University of Eindhoven trying to make fuel out of metal dust. It's crazy, isn't it?
Oh.
Actually, not so much. That's one of my upcoming videos is using sodium as a fuel.
Really?
Yeah. Because it turns out that it's possible, right?
Yeah, well, it's an exothermic reaction, so.
But
how is energy per mass compared to petrol?
it's actually not so bad, but I did the calculations. I think it's a factor of 3 down. So now, obviously, 3 times the weight of fuel is kind of impossible. You can't triple an airplane as it stands. You can't. You triple the weight of the fuel, and that's the weight of the plane.
Yeah, sure.
So,
the sodium is a metal, right? Are you going to burn it in metal form?
No. You're going to melt it. It's going to be transported as a liquid, but that's only like boiling water type temperature, so that's not too bad.
And you keep it below oil or something.
You don't really need to if you got 100 tons of it or something. But the thing is that at the moment, sodium is just way too expensive to use as fuel because no one uses it commercially. There are no applications for hundreds of tons of sodium. But in principle,
mean, like, what about streetlights?
They use almost none, and it's not burned. Yeah. So this is the thing. When you burn, it would be a hybrid engine. So the first part of the engine is just a regular jet engine. So what comes out of the back of a jet engine is carbon dioxide and water. Now, it turns out that the sodium will burn in water. So you actually inject sodium in the back of your engine, which makes sodium hydroxide, which then also reacts with the carbon dioxide, maybe actually in the engine, maybe later, doesn't matter. But the point is, at that point, it's a carbon dioxide neutral engine.
Yeah, right.
And if I remember rightly, the
make a Kickstarter then, because you're saving the planet.
That's but the downside is, of course, and yeah, I know this because I've actually done it. You can burn this stuff in steam or just water vapor, no problem. Right, so getting the energy out is no problem. Things that might be a bit trickier is
storing it.
putting a few tons of sodium onto a plane at a time.
Yeah, storing it safely.
But it's right.
More
So
funny if the plane crashes somewhere in water.
right. So water evacuations might be a little trickier. And there are right. There's another great advantage to this, of course, is first of all you fly the planes higher, right? Because at the moment the limit for where the planes fly is compromised between you need enough oxygen for the engines.
Yeah.
So if you go too high, you don't have enough oxygen.
Yeah.
But if you go higher, there's less air resistance. But with this, first of all, you need less oxygen because your engine is only, I think it's 2/3 running on gasoline. And then after that, you're using the steam from there to react with the sodium for the rest of the energy.
So you're running very lean.
Yeah, so you can actually fly higher.
Okay, right.
In principle, the downside.
Have you found a test pilot yet?
There are so many problems that. But one of the other nice things, of course, is that you're depositing all this sodium hydroxide, sodium carbonate that you're making. You're actually legitimately making chemtrails now.
Yeah, that's awesome.
Right. So first of all, they're carbon neutral. Secondly, they're nucleation centers. So you can
for cloud seeding.
Exactly right,
Yeah.
and it's so there are parts of this that are not insane. There are other parts that are. If you take a look at current sodium prices, not a chance, right? However, in principle, the only cost of making sodium is essentially the cost of the electricity to run it. You're essentially just using your sodium like a battery here.
Uh-huh.
And then you're taking electricity which you're going to get from solar power or something like that.
Nuclear.
And then nuclear, yeah. And then you're using that to run a carbon neutral engine that also creates chemtrails that reflect more light into space. So
that's a nice
This sounds
scheme.
good. Yeah, this is amazing. We can see the future and so on.
So the thing is, the thermodynamics work. I've done the thermodynamics and the mass balance, and it's possible. You can. I think it's.
You could find out if someone else thought of it if you look in the patent databases for something like a sodium injector or something, because that is something you would need to make very small particles out of the liquid to inject them into the
that's actually one of the easier things. It's just the liquid. You just inject it as a spray. So.
Yeah, but I think it doesn't spray very well, or the metal stuff. It will form
It's got high surface tension, but it's about the same as water.
What is the melting point of sodium metal?
It's about the boiling temperature of water. It's 100 degrees Celsius.
Oh, really? Because I am trying to melt sodium chloride, table salt.
About 850.
Yeah, that's about 850. So that's a whole lot lower.
Yeah.
It's not easy at all.
No, the problem with melting sodium chloride is that there's always some kind of water in there, so it will start popping like a bitch. So
it burns.
Yeah.
You get the little bits on you.
Yeah. So I'm trying to figure out a way to melt sodium chloride without getting burned all the time.
So I think the way it's done commercially is you put calcium chloride in there, which lowers the melting temperature. Yeah, so eutectic,
Yeah. Cool. So guys, I'm going to leave you all. It was very nice meeting you, Phil.
Wait a second. There are crucibles from graphite that have a lid. Just search on eBay.
Oh yeah.
That should work.
Or nickel. Could I use nickel?
Nickel would be fine.
Yeah, because I don't care about corrosion or anything. I just want it to melt.
It's actually a pretty tough deal getting. Because the hotter you get, I forget what it is. I think it's to the power of 3 or something.
Yeah.
It radiates the heat away much quicker as you get hotter.
I use borosilicate glass, and I can tell you all, don't try it because the borosilicate glass will give away long before the salt will go.
Yeah, but the idea with the carbon crucibles is still a good one, because you can waste a lot of them. They're quite cheap, they're replaceable, and I also advise using the carbon crucibles. They are really good. This guy, Cody's Lab, some American guy, he makes a bunch of cool videos. He uses all kinds of crucible to melt stuff. I think he also demonstrated some stuff with carbon crucibles, and it works really well. Yeah.
Okay.
The carbon crucibles just get a bit thinner over time when you use
because some of the carbon burns up. Yeah.
But
Okay, have a nice meeting.
Yeah. Bye
Bye-bye.
Bye.
yeah, so I've actually got one of those carbon blocks downstairs, graphite blocks for casting metal bars. They conduct heat like crazy.
Yeah, that's also good.
And electricity.
Yeah.
I used I once melted silver and gold, and I used induction heating with
You need a big power source for that.
I just used 1000 watts as CVS driver from eBay.
But you sort of put the big clips onto the graphite block and just let it go?
No, induction.
no.
He did not.
Oh, induction. Yeah, okay. Yeah, okay. The big metal coil.
Yeah.
Pumped
After an hour, the water I pumped through the coil was warm enough for bathing. So there goes quite a lot of heat.
So how much did you melt?
About 5 grams.
Okay.
I made alloys myself, and well, just for where is it? A necklace. But yeah, it works fine.
Cool. Just out of interest, has anyone else had an absolutely filthy cold this winter?
Yeah.
This weekend, the last 5 days, 3 days ago, I could not have attended this very meeting because I was down like half dead. Really.
So
really
it sounds like you got what I got. And it's just, right, normally it's a 2-week cycle when you get the flu. But this one just wiped me out. You know, the first 2 weeks, I was sort of just wiped out in energy terms. I mean, and this is 3 weeks on now, and it's still lingering.
Mine was very quick, very brutal, but went away after like 5 days. So I'm feeling quite fine. I will go to work tomorrow. I didn't plan on last week, but now I feel fine enough. But on like Wednesday last week, I could not even get out of bed. I was smart enough on Tuesday when I felt the first symptoms to stock up on everything I needed right next to my bed. And on Wednesday, I could not even get vertical the entire day. And this was basically for like 2 days, really, really hard. And then it went better, and now it's okay. And very
So
unusual.
it's just this was the same with me. Huge levels of fatigue.
Yeah.
Just getting up and doing stuff was exhausting.
Yeah, and nightmares, high fever nightmares. I dreamt so much shit, you cannot believe it. When you have fever and you want to sleep, what your brain is making, it's absolutely brutal.
This is amazing, right? So you get this as well. That you can tell when you've got a fever because when you sort of close your eyes, there are all these sort of hallucination type things.
Yeah. And I played some computer games on Tuesday evening, and basically the next 2 days, all I did in my pseudo sleep, it was not real sleep, solve that last level that I played on Tuesday over and over again, and it was unsolvable and brutal difficulties. And I tried to solve other problems with the same approach I used in the computer game. So basically a nonsensical lockdown, and then I woke up and I banged my head and said, come on, sleep now, don't think all this crazy stuff. And then was a little bit relaxed, went to sleep, and then it went again into the same loop, like a calculator trying to divide by 0 or something like this. Really, really brutal. Yeah, I think I lost like 5 IQ points during that. I hope they will recover.
For me, it was the worst flu I've had for 20 years. This apparently killed like 5,000 people in America or something, which is
yeah, quite a lot. And I think also in Bavaria, some people died. Older people, children this time. I think this was uncharacteristic for this flu that it killed so many very young people. Yeah,
I had it in January, exactly there where I had to go to the in Germany mündliche Prüfung for my for the end of my apprenticeship.
So oral exam. Oral exam.
Oh
mündliche
yeah.
Prüfung is oral exam. Yeah.
Okay. And I was so ill, but I went there anyways, and I finished my apprenticeship. So I'm now a mechatronics technician.
congratulations.
Thank you.
Have you had some job interviews already?
What?
Have you had some job interviews already?
No, my the working facility where I was took me. So
so that's solved.
Yeah.
Yeah, you like it there?
It's okay. I'm in research and development.
Yeah, because my advice is very often the companies that do like the training. In Germany, you have, Phil, because you're not from Germany. In Germany, you have a very strong branch of professional training that is these Ausbildungsberufe. They don't play a big role in many other companies. So basically learning a trade, not at university level, but with the company at a professional level, but this in a very controlled and certified way. I think the Americans don't have this at all. Basically there with enough experience, everyone call themselves a carpenter or something like this. And in Germany, you have basically some kind of training until you are Industriemechaniker, Mechatroniker, carpenter, or whatever. And a lot of the companies use that opportunity to find among the people they are training, the ones that are good. And then when the training is over, they make them an offer and take them into the company. So my advice to you, young German fellow, would be don't sell yourself too short and test your market value with 1 or 2 other companies. Have a few talks, let them make you a few offers, and maybe you find something that is even more interesting because your qualification is one of the more interesting ones, I would say. And so maybe there's a good opportunity somewhere else.
I thought about studying, but
yeah, and that's also always a good option. Yeah.
At the moment, I'm burning my money with stuff like this, and
that's well made. I mean, that really is.
No, you can't tell. The vacuum will tell if it's well made or not.
That's true, but it looks good. Actually, this is another thing. So that's just Perspex, is it? That thing. Oh, it's an inch thick. Okay, 2.5 centimeters thick. Yeah.
No, 1 centimeter exactly.
Yeah, it's solid enough to hold a vacuum though. But you get a hell of a pressure on those things.
And this is plexiglass. Is this plexiglass or is this
polycarbonate?
Polycarbonate. Okay, yeah.
And on my monitor, I see the Spannung, the
tension,
the stresses in the polycarbonate because of the monitor. It has polarizing filters, so I can see the stresses in there. That's cool.
And just so you know, we can see you've got gazillions of tabs open. Looks almost as bad as my computer.
Yeah, it's the Toblerone mode of Chrome.
Yeah.
But I do exactly the same. I just have so many tabs open that, this might be useful. I won't close it yet. And
yeah, my next computer will have 128 gigabytes of RAM.
Yeah.
I have just 18. To my cap bank. I didn't test it to the full voltage yet because I realized it's too loud for just a headset. I have to get something like Oropax for in the ear to for
to
an
protect
extra
the
level.
ears.
Yeah, the cloud of plasma that flashes up after a discharge for a brief moment is at 20 kilovolts at this big.
Yeah. Okay.
And that's not even close to the 70 kilovolts that this thing is tested to.
Okay.
What's the capacitance on that?
I measured it. It's 2 microfarads.
Okay. So lots of voltage, pretty low capacitance. I bet it's a very low series inductance too. Is it made for pulse discharge duty?
Yeah, it's a friend opened them and changed the oil, and he said the coils are bifilar, so the plates are wound in a style that they have a minimum of inductivity. So the only limiting of the pulse current is the external cables and stuff.
Okay. What are you using to discharge this?
Air.
Okay. So it's just an air gap. You set the gap and charge it up and it'll jump the gap? Or do you have some sort of mechanical setup to bridge the gap?
Not yet. So to discharge it inside here, I haven't. I don't have anything yet to discharge it, but yeah, I try to think about something because at maximum voltage it's 60 kilovolts. That's how far I will go with this, and at 60 kilovolts the gap it jumps is
it's quite a large gap.
6 centimeters. Yeah, 10,000 volts a centimeter.
Yeah. So how do you, let's say it doesn't trigger, how do you discharge it safely?
I have a cable with a stick on it, a glass stick, and I just short it with this.
You should maybe get a long resistor or something to do that with. I mean, especially if the stick is glass. I mean, that's a lot of energy. You could possibly shatter the glass. And also, you could damage terminals too.
I'm a fish out of water on this one. I know that 60,000 volts is 6 centimeters in air, but beyond that,
for DC, yeah. See, I actually do have quite a bit of experience with high voltage. I built Tesla coils for the better part of 10 years. So, and I was on. You familiar with the show Jimmy Kimmel Live? Yeah, I was on that show in October of 2014. So,
all right.
Yeah, I rented some of my equipment.
I once made a Tesla coil with one of these capacitors. I'll tell you one thing. I grabbed the screwdriver like this, but it discharged all the way. And it hurt. This thing hurt so much.
Yeah, you need to be careful. That's the kind of energy you're playing with. I mean, that's not just like going to be an ouch. That's like, you might be blowing parts of yourself off.
Yeah, also when one of the capacitors does not take the stress anymore and blows up, then this also will have catastrophic consequences.
A friend of mine tested them, and after he exchanged the oil, and he tested it to 70 kilovolts, and I will only go to 60 kilovolts to have
And they are rated for this, right?
Yeah. Well, they were rated to 15 kilovolts, but they are now tested to 70 kilovolts for over 5 hours under oil, because at 60 kilovolts the gap jumps between the terminals.
Right. So you're aware that, like, you know, maximum standoff voltage is different from what the capacitor is actually going to endure in pulse discharge mode, because it's not the voltage you charge it up that's going to kill it. It's when you discharge it through your gap, there's going to be current that comes back. You know, it's a ring down.
Right.
So it's going to reverse on the capacitor, and that's what does the damage, because it's essentially like a really high frequency, high current pulse. So
it's not tested with the professional testers. It's tested with a Tesla coil and a Röntgen transformer. It was continuously discharging for over 5 hours and didn't kill it.
So on the Tesla coil, though, you will have a primary inductor, which is going to greatly limit your discharge current.
Yeah.
When you dump it into your wire, the current will be much, much higher.
Even if they blow up, the friend of me will restore them.
Okay.
Because they are not cheap.
No.
One of them, I got 4, and one of them is 50 euros without shipping, and shipping is per part 50 euros.
Oh, well, that's actually not so bad for a pulse capacitor. I mean,
yeah,
you know, new, those are probably thousands of euros. So
they were made
brand new
in the old UdSSR.
Okay.
And they are really beefy. The isolation is only oil, and the spaces are ceramic. Yeah.
Ceramic?
Yeah.
Huh. That's interesting. Most of the you know, high current pulse capacitors I've seen are film. They use you know, polypropylene film or sometimes Mylar, because they have very good dielectric properties.
Yeah. I have another project at the moment, but it's kind of shut down for a while because I don't have time to program things. I want to build a train, a mini train, so like a toy train, with magnetical levitation, so it drives without friction.
Yep.
And I wanted to put it
in a vacuum tube.
Exactly.
Because this is the thing that bugs me. I'm not even so sure anyone's actually built a model, a working model of a Hyperloop.
Yeah.
You know, it's just something that runs under vacuum. Well,
Exactly.
What about the kilometer-long thing that you visited?
That's not a model.
So the Elon Musk one, that's crap. But the Hyperloop One thing, they actually do, I think, have it running under vacuum as a maglev. So they've sort of done it, but the thing is, they've done a kilometer with no people.
Don't hate on Musk now, because did you watch the Falcon Heavy test, Phil?
Yeah.
The two boosters coming back were very impressive, I've got to give it, and they were actually refired, but the middle one crashed. Yes.
Yes.
Yeah.
And almost sunk the ship again.
Yeah. Well, it hit it at what, 300 kilometers per hour or something.
I think it hit like a few hundred meters away or something. But I mean, you could see when you watched the live feed that you saw the screen just go, and it was all cloudy. And then the presenters were like, "Oh, yeah, sometimes this happens because the barge shakes." It's like,
no.
They ran out of fuel.
No, one of the engines did not light like they were supposed to.
Oh,
yeah, and so
one
engine is strong enough to keep the entire thing and basically also to launch the entire thing. But they calculated with more engines, and so because only one came on, they ignited too late, and so yeah, that was the reason why it did not work.
Yeah.
And it goes
They run
like
out of
this.
TTB or something.
It comes down, and when they know that both engines went on correctly, they make a slight course correction, and only then this new course will bring it on collision course with the ship. So when only one engine came on, it was still on a trajectory that it would hit some spot with water next to the ship. But with all the fuel that was now superfluous in there,
it made a bang.
because only one engine was also able to burn off the fuel, so you did not land like nearly empty, but you had a few hundred kilograms of fuel unaccounted for, and then bang. That's the right description. Yeah.
But I mean, for me, I'm still really skeptical that this is the revolution that it's often portrayed as.
We are not living, we will not have rocket revolutions. We will have tiny improvements. And if you improve like 5% on 10 different fronts and multiply all those up, then you get to a significant better competition compared to the rest of the market. And I think that's where he's going. He will save up a little bit here and there, and then in the end,
all of this is actually contingent on it being as reliable. Because when you're into the multiple relaunch things, right? Okay, you save money by relaunching them. But if you actually have sequential decrease in reliability, it's worthless.
Yeah.
Right? You need to maintain that reliability throughout. So the real questions is what maintenance do you have to do on those engines to actually keep the reliability up? And all getting the rockets back is a start, but it's they got the shuttle back and reused it, but it's just that the maintenance costs of refurbishing the engines was actually higher than they could have just built the new craft. So now, all right, there are all sorts of inefficiencies with the shuttle program, but for me, I'm still deeply skeptical that the thing that Musk does is well, if we get it down to just the cost of the fuel, we can launch them 100 times cheaper, and I don't believe that for a second.
I have a test question for you now, Phil. When was the first docking maneuver between a Russian and an American vessel in space?
Well, I would go for the Skylab. It was post Apollo, yeah. I mean, I'm going to guess that, but there might be some earlier one where. No, I don't think so. Is it not just the friendship module? That was the first time the Americans and Russians shook hands in space.
I think you're onto the right story, because most people think this was after the end of Cold War when Mir.
Oh no! Yeah.
Wasn't it Gemini?
No.
So it's,
Gemini was the first docking. What they called docking back in the day was, could you actually get up to another vessel in orbit?
So give me a rough number for the year.
It's after the end of the Apollo mission, so I'm going to go. And they had a few Saturn V's left afterwards, so let's go for 73.
Almost 75.
Yeah.
But I did not know about the story until like a week ago or so, when I stumbled upon it on Wikipedia.
It's
been during the Cold War, and indeed it was a mission to rebuild goodwill between the nations. So basically, this was the idea, and
didn't work out so well. Yeah, another 15 years of Cold War, and
and the Americans did a nice thing after they undocked. They put themselves in front of the sun and created an artificial solstice, so that the Russians could take pictures of the corona.
That's actually
that's beautiful.
What one can't but help feel there are cheaper ways to do that, but it's a nice touch.
Yeah,
it's very, very chivalrous.
Yeah. And I think the Russian mission took like 6 days, and the American stayed a little longer in space, so it took like 10 or 12 days. And it was a modified command module, a modified Apollo command module. They had a few of those over. And so, and the Russians had a lot of stuff for like multiple people in space, because they were also going into like doing space stations and stuff. And the Americans had to improvise a little bit, so they used a Apollo command module that was still left over. And the interesting thing is, the Russians ran their spaceships with an oxygen-nitrogen cabin atmosphere at about 1 bar of pressure, which is very nice for the astronauts, because it's like the same conditions they have here, basically. And the Americans optimized it, ran with a pure oxygen atmosphere at a 3rd bar of pressure, so they would have to bring less superfluous mass with their spaceships. And so when they docked, I think for both crews, their ears popped a little bit, because I think when they opened the docking clamp, they had to agree on some common pressure levels. And so they installed a pressure hatch so that they could like
equalize the pressure.
Pressure equalization.
But even at that, that's a lot of pressure. That's like 2/3 of an atmosphere.
Yeah. And I must say, the Americans were crazy with the Apollo and the oxygen atmosphere, because, like, I would not want to be in a room with a 100% oxygen atmosphere. It would just
and it's not just that; they overpressured it with oxygen on the one that caught fire, Apollo 1. They overpressured it with a, it was. They had to overpressure it to like blow all the extra nitrogen out of the capsule or something. It was like just such a super crude way of doing it. So, but yeah, I mean, it's insane. In fact, it's one of the things that I've got on the long list of stuff to do. Is I got one of these giant cans, which coffee beans came in. So it's like a 10-liter metal can or something. And I was just going to make a little mock-up of one of the, basically what the inside of a spaceship might look like if you get a fire. And of course, it'll all burn up in seconds, and the thing will explode, because you get like 20 bars of atmosphere. Well, it basically goes up till the whole thing explodes. The spacecraft was only meant to deal with 1 atmosphere of pressure anyway. I think with the Apollo 1 fire, it went up to about 5 bar or something before it burst.
Yeah, I'm a computer scientist actually, and last week I stumbled upon something that I find very, very amusing. So I would like to show you real quick.
Sure.
And this is basically what you see here. Is a JavaScript implementation of Microsoft Paint. Some guy did this, and it works just like we are used from Paint, except that it is in a browser, and it is all in JavaScript inside the browser, which I find curious, because when I used Paint back in the days with Windows 3.11, I would paint a line like this, and then use the flood fill tool of Paint to fill it. And then it was a little curious, because you could see it changing color. So basically it changed color just like I'm simulating here right now, just like this. It would change color in real time, and you could observe it, and you could take the time. So I sent this bitmap file with this to my friend, and he sat there with a stopwatch, and on this computer it took like 16 seconds to fill the bitmap, and on my computer it took like 25, and so his one was better. And when we got new computers and stopped running Windows 3.11 and instead start running Windows 95, then we observed that it did no longer work that way. You could no longer observe the progress of the stuff, and it was so fast for all the bitmaps we used earlier that we could not longer measure the time. So it was like filled in a couple of microseconds. And so later I put it to extremes, and I did something like this. And this is the same stuff. It is also a line. This is, of course, in a resolution that would take too much memory for one of the old computers to load it, but my computer loads it just fine. And when you look at it, then you will find out that this first one starts with, with a step. And when I scroll down there, the first one starts with a gap, and then it is the same pattern. So basically, this is a 1 pixel long line, and at some point it's connected to the solid red stuff on the left. And so when I fill it, and then I click, it takes like a second, and then it changes immediately on the entire stuff to the new color. So let me start MS Paint. You open this file. So basically, this is JavaScript in a browser. So basically, it's a script engine inside a script engine inside a script engine inside a native C application or something like this. So it should not be that fast, but it is quite fast. It took a second to load that. This is the native implementation of Paint for Microsoft, and it also has an implementation for this flat fill algorithm. So what are your bets? What happens when I hit this?
It's going to be knocking down dominoes.
Yeah.
You'll be able to see it go pixel at a time.
Nope. Other guesses?
It'll crash.
Yeah, very close to it. So I just hit the button. Nothing happens. After a few seconds, there will be this image not responding message pop up.
Out of memory.
It will use over 100 megabyte. It will use over 100 megabyte of memory. So this is basically the task manager.
Oh God.
Using 125. I just noticed my CPU fan starting to spin a little faster because it's using one of the cores.
And you look outside and all the lights are dimming.
Yeah. One of my cores run at 3.4 gigahertz, but it's quite fast. Now one of the cores is even overclocking and running at 3.6 gigahertz. So basically induced by Paint, and it will go on like this for hours. And then it will finally fill it. And if you count the number of pixels and divide by time, then you will find out that these 3.6 billion processing cycles a second are only able to fill in the hundreds. So less than a couple of hundreds pixel per second with the flat fill algorithm of native Microsoft Paint implementation. And I find this highly curious that some guy, and I talked to the guy who did this JS Paint implementation and congratulated him to his good implementation of the flat fill algorithm. And he thanked me a lot because he was not even aware that flat fill was such a difficult algorithm and did not even do this extreme test. And by accident, he did an implementation that outperforms the Microsoft implementation by, let's say, 10,000 orders of magnitude or something like this. Very nice.
There's got to be a bug in that or something. Yeah, I mean, because it's all you're going to do is take one pixel and you look at the adjacent pixels, and if it's the same color, you fill it, and then you move on to the.
Yeah, but I think they wanted to be smart, and you have to do it a little bit smart because let me switch back to the webcam. Hold on.
Okay, so you see it in 100 places. You take 100 random pixels that are the right color.
Yeah, because something
and
can
then
happen
you
like
flood.
This. If you just build the next one, you could come full circle, and then there could be a conflict who is responsible for filling a certain pixel. Then also, when you build your stack tree, so basically the way where your code goes into different branches, you do not want to have that indefinitely deep, and you don't want to have that indefinitely broad. So basically, from a computational thing, and the C compiler does funny stuff, you have to be smart with this algorithm in order not to break stuff. And they broke stuff because I did the same test on Windows Millennium Edition back in the days, and there it would crash the operating system. So you had like, after you started it, you had like 5 more seconds to get the hell out of there and kill the process. And if you don't act in those 5 seconds, then the mouse pointer would start moving slowly, and then the operating system would freeze. Yeah. And you would have a blue screen in the end. So it would go down with a blue screen. At least on my machine, maybe not on all machines, but at least on my machine. So probably they fixed that clusterfuck, and by fixing it, they introduced a conservative approach, and then they didn't change the code for like 10 years. I think this code is in there unchanged for more than 10 years. Yeah.
Well, I mean, the thing is that Paint genuinely looks like something from Windows 3.1. You would have thought that, given that, a crude sort of pixel editor type thing is among the simplest things to write, why don't they just put an updated version? I mean, they really are. Not that, yeah, they're one of the simplest programs to write. Yeah, but a simple paint program.
Yeah, I think I can just pull the image in chat. Can I share this picture with you here directly in Hangouts?
I
think so.
hope so.
Upload.
Well, you could tell a programmer he should program this in assembler.
No,
No,
that's way too.
Well,
No,
it doesn't help to
don't.
put it in assembly if your algorithm is still crap.
Yeah, if the algorithm is crap, the programming
Yeah.
does not matter. Yeah.
I
Yeah.
program the pics in assembler in pic assembler. It's 35 commands and works fine.
Yeah, usually no. When it comes to optimizing, the compilers today are so good. Usually you do not do runtime optimizations in assembler. So basically, if you want to have an algorithm that uses less memory and uses less runtime to solve a given program, then you just make your algorithm better and make your C or C++ implementation of that algorithm better. You only use assembler if the program itself needs to be very, very, very compact. Then you start going into assembler to optimize on the size of the program itself. Yeah. And if you have a lot of money, then you're doing it with assembler. Yeah.
I have no other choice than programming pics in assembler because
you don't have an operating system. Yeah, then also you do it in assembler, of course. Yeah.
You only have 2K of flash.
Yeah.
But
this is what I said, when your program has to be really small, and this is also the case in your case. Yeah. And I must say, my heads off to you, because programming assembler I would not do it.
Nightmare.
If
I wouldn't even try either.
If you don't like assembler, you should try VHDL. It's even more fun.
I don't even know what that is, but if it's worse than assembler,
it's what you use to design hardware for FPGAs.
I was going to say, some of the ASIC stuff as well. You're doing the HDL.
Yeah. So basically, it's programming hardware, Phil.
Yes.
Yeah.
Yes, that's what I do. So
that's my programming hardware.
Is that custom made?
Self-built. It's one of the only PIC programmers that really work, because when you buy one, it tends to break the chip or doesn't work at all.
You're all crazy unless you sit there and weld the transistors together, one transistor at a time.
I thought
that's
about
how a real man does his.
Well, you can make everything with like 7/4 series logic or something, right? You know, like the little 14-pin ICs. You can get like 4 AND gates and all. Yeah.
I have 800 transistors here.
One of my friends who I used to work with actually built a telephone exchange out of 7/4 series logic.
How big was it?
It was reasonably large, shall we say? But it was very primitive as well. But he actually built a telephone exchange out of 7/4 series logic.
That sounds pretty cool.
Yeah, I think it didn't last very long, but what can I say about that?
Yeah, it's crazy how far things have come now. Like I got FPGAs sitting on my desk that's like, you know, you couldn't even fit all the 7/4 series chips you'd need to replicate what you can do on that in a single room. So, let alone powering it.
This is a transformer I wound a few months ago.
Is it high frequency or something?
Yeah, it uses a broken transformer core from a old television.
Oh, the flyback?
Yeah.
Okay.
The super high voltage things.
Yes.
I 3D printed the part where I wind the coil on, smashed pressed the broken core inside of it, and put it in a jar. Like, wait a second, where it is? No, that's not my vacuum chamber. I made a vacuum chamber out of marmalade jars. I can't find it right now. I took the raps oil, really cheap oil, and vacuumed it for about 2 hours. So the oil is almost water-free.
Okay.
And then I put all here inside. Nice few wires, a lot of hot glue. And yeah, this thing, I put so much power on this, and so much voltage, I wasn't able to kill it.
What kind of sparks will it make?
Like so.
Oh, that's pretty good.
And when I drag it,
broken-
it's like this.
So was the ferrite core itself actually cracked, or was it just the transformer windings were like burnt up?
I would guess it's almost always the windings that fail, yeah.
The windings burned up, and the
Okay.
core was broken because it was glued in, and I wasn't able to get it in one piece out. So I only had the center core of this.
I guess you get some leakage then, which is probably good if you're doing like a ZVS driver.
It's not a closed loop anymore. I have one unbroken here and my ZVS driver. This is my ZVS driver because my MOSFETs burn up quite often. I can
Oh, that's nice.
pull this out.
Quick change.
Good.
Do you have other ones ready to go?
Quite a few.
Oh, I meant like on the heatsink already. So you just pop it and then put another one in.
Yeah, in a belt probably, so that he can quick
Yeah.
run and bam and go. Yeah.
And other parts broke too at one point. So
I've been there for sure.
When it releases the blue smoke.
yeah, the magic smoke.
Oh, that
If
can
a
be
part-
really fun. Sometimes with power electronics, it doesn't just let smoke out. Sometimes the failure will be such that it'll sustain an arc, and the arc will
Yeah.
crawl around on the components and start eating them.
I don't
until
know
you
if
remove the power.
if they sell them anymore. There was this X-Mods type of car vehicle of remote cars, and there was extensive aftermarket tweaking available for it. And when me and my colleagues and me got a lot of X-Mods and were doing in the garage the racing, yeah. Oh no.
What is it?
That's one of the
Okay,
transformers
fly back.
used, and it's like a closed loop, but this part broke off, and
Right.
I only had the center round piece, so I tried it and it worked well.
That's cool.
Yeah. And for the X-Mods, I also had a lot of spare parts to solder on real quick when something popped, because in the end it was so overpowered that it was hard to have a stable run for a longer time. Yeah.
The soldering took too long, so I found these things here in the hardware store nearby.
Yeah. Ah, okay.
They're quite useful.
What's your switching frequency? It must not be
Oh.
too high if you're using those.
I haven't measured it. I think it's about 80 kilohertz.
Okay. It's
And
relatively high, but not too
speaking
high.
about broken components, here's one.
Oh, yeah, I've got a lot of stuff that looks like that.
It got quite thin.
Have you ever seen they make much bigger switch modules that they come like built in a package that you like has screw terminals and everything. They're like
Yeah,
IGBT modules.
I got one, but I don't exactly know where it is. No, I won't find it probably.
So, Phil, what kind of videos do you have on the
It's
horizon?
gone really 44.
I had something in mind, but I lost it. Oh yeah, I texted you a few weeks ago with a topic, and I had the idea to take a thin tube and fill it with deuterium gas and discharge my cat bank through this.
Presumably
I
low
came-
pressure, yes?
I came up with this because I took a glass tube and made shoved an electrode in the middle and made a ring electrode on top, and then discharged one of the capacitors through it. Well, I had my face mask on.
Yeah.
I
For
like
safety.
where this is going. Yeah.
And
I
yeah,
would have done this with low pressure. You heat up gas in the tube and it's
the tube was
Exploded.
Yeah, it completely shattered.
You put 4 kilojoules into a tube, it's gonna get pretty hot, whether it's low or high pressure.
No, it was only 1 kilojoule at this time.
Okay. That's still quite a lot of energy to dump into that tube.
Yeah. I calculated the pressure to be about 1,500 bars.
Yeah, okay. That's about a factor of 1,000 higher than it should have been.
At the temperature of about 750,000 degrees.
Okay, it's going to be non-linear at that point. Otherwise, you'd be into the fusion regime. But
yeah, that's the point.
you're 2/3 of a million degrees in a tube.
I calculated with the 4 kilojoules and a shorter tube. I would reach about 7 million degrees at a pressure of about 7,500 bars. And
Actually,
I don't know if fusion could happen at this pressures and temperatures, so I texted you before I would try. But because I didn't want to get irradiated with neutron radiation, because
don't worry about that. This will not happen. Yeah.
But I mean, my guess would be is that the gas cools as it hits. No, but the thing is, the middle of it, you're talking really short time scales here. I mean, what time scale are you talking for the discharge here?
I recorded the discharge with my Casio Exilim, and
so it's less than a millisecond.
Yeah, it's less than 1 frame.
Yeah.
The light is.
It's going to be on like nanoseconds. I mean, with that kind of capacitor, that's so little inductance. I mean, really, you can determine your discharge time by just, taking the capacitance and the inductance and, calculating out what the resonant frequency of that circuit would be.
But the other thing that I think you got to be a little careful of is how much of the energy is actually dumped into the gas. I'm not so sure. A plasma, it conducts the electricity really well. So how much, once it essentially becomes a metal, in terms of conductivity, you're not dumping as much energy. Well, I don't know. I mean, this is outside of my realm of experience dealing with that sort of temperature plasma.
Yeah. I didn't have an answer to this question. What would happen? So I texted you, but I don't think you read it yet.
Yeah.
But I also wrote there that you can that you don't have to text me directly back because I knew you were moving. Yeah.
So I've done something not directly similar to this, but there was a time when I had to measure the spectrum of hydrogen, and I basically did that. Yeah, I took the high voltage thing out of a plasma ball and just used that to discharge through hydrogen, and
that's not much power.
No.
This time has more power. This thing.
No. Okay, it's gone very stuttery for me.
Yeah, it keeps breaking up.
I remember what I was going to, and so just when I was doing the discharge through hydrogen, I was putting out some fairly hard ultraviolet. I was curious to actually get to. So I took a gamma, not a gamma, whatever, alpha, beta, gamma type detector,
Gamma Scout.
Gamma Scout, yeah, and that went absolutely crazy. And then I thought, wow, that's really cool. It's giving off X-rays. And then it turns out it's not. It's the whatever, the high frequency just triggered. Yeah, it's basically direct interference between the high frequency whatever, the transformer, and that's enough to actually trigger the Gamma Scout.
Yeah, I mean, it's not surprising. It's essentially designed to do that. That's how the plasma ball works, right?
So when you have gammas 5 centimeters next to it, you will have gammas at the other side of the room. But at the other side of the room, you don't have the interference with the high frequency transformer.
Yeah, that would do it. But I mean, you said I was on fairly low power stuff anyway, but nonetheless, I had a suspicion it was putting off the ultraviolet. I was just wondering how far into the ultraviolet it went. But yeah, I mean, for what you're talking, I could well believe that you'll be getting off X-rays and all sorts of nasties.
Oh yeah.
Oh, okay.
Especially at those kind of voltages.
Yeah, well, what I'm curious about is how much of that kilojoule actually ends up in the gas. In other words, if the electrons just go down, they end up heating. I don't know where the energy ends up in that thing. Yeah, if you essentially discharge it through plasma, which is more or less the conductivity of metal. I don't know if that actually heats up like
this try here was with air, and it was open on one side, and it shattered. But
actually, now I think about it, you don't actually gain that much by putting in the glass tube. The only reason you need the glass tube is for the deuterium, for the hydrogen. Yeah, if you're doing it with air, just sort of do it across a gap.
What exactly was the question? I didn't quite get it.
So you're discharging a kilojoule of energy through hydrogen gas, yeah?
This was through air, but I want to try it through deuterium gas.
Yeah.
And I don't know what would happen, so that's why I wanted to ask you.
So there are these things called Farnsworth something or other, Farnsworth generators?
Farnsworth fuser.
Farnsworth fuser, there we go. And with those, how do they work? Are they just really high voltage accelerating particles smashing into things, and they give off neutrons, I think?
I think these things are at a really low pressure.
Yes.
Yep.
Just applying high voltage to the gas, I think.
Yeah.
I don't really know.
So you're doing that, but higher pressure.
Yeah, with more energy, higher temperature, I think.
I think you need a stronger tube.
We're going to need a bigger tube, yeah.
Maybe I'll epoxy the tube with about this much epoxy.
Yeah, but the glass will still be thin.
With this was funny. The tape either melted or I don't know. It's silicone tape, but there are places where it's almost
melted.
Gone. Yeah. I have the video of this where I discharge it, and it's black tape. It's multiple layers, but you can see the light anyways.
Okay. So are those two wires? Those are on either side of the capacitor, so they're different potentials, right? And they go right by each other.
The glass tube was up to here, so the glass tube isolated it.
Oh, so that's just the end. The rest of the tube is missing.
Yeah, this part wasn't wound up that tightly with the tape, and it turned to dust.
Yeah, I mean, this is the sort of energy density that makes conventional explosives look like sissies.
Yeah,
it might be interesting because you got a tiny little tube there. How big's your tube? It's about let's say it's got a cubic centimeter of gas in. Is that about right?
I calculated it to be less.
Okay.
I can measure a tube like that. Wait a second.
It's all right. I mean, order of magnitude's fine for this. So mole of gas is 22 odd liters. That's 22,000. So let's say you've got 1/10,000th of a mole of gas, and hydrogen weighs a couple. So it's 1/10,000th of a gram of 1/10,000, give or take. 1/10,000th of a gram, and you're putting how much? A kilojoule into it?
4 at the.
Let's call it 1. Let's not be too picky here. And hang on. Right, so yeah, 1/10,000th of a gram with 4 kilojoules, 4,000 joules.
That's the inner diameter. So it's about 3 millimeters inner diameter.
Right, so just so you know, it's let me count the zeros here. 1, 2, 3, 4, 5, 6. Can't quite. I can never count the zeros in these. Let's try 1 to the 6. Okay, 40 million joules per gram is what you're talking. And if I remember, TNT is 4. 4 mega, 4, no, it's going to be 4 megajoules per kilo, isn't it? 1 second. Energy density of TNT. I think
This
it's
is
4,
assuming complete dissipation of all the energy in the gas.
more or less, yeah.
Yeah.
But I mean, I'm saving off factors of 4 and here and there. I'm just after a ballpark number. It's
Yeah, but we still don't know how much energy goes into the gas, right? Because I think this could be like 2 orders of magnitude or so.
Yeah. So either way, we're talking about 10,000 times the energy density of TNT is what you're looking at.
Yeah, that's not so bad.
Yeah. The thing that saves you, of course, is you've only got one. What do you say? 1 milliliter? Yeah. So it's a thousandth of a gram. Is that about right?
Yeah. Well, in the end, what it saves you is that you only have a kilojoule.
Yeah. You gotta. Yeah.
To begin with.
I'm going to go ahead and predict that the result of this is that there will be some water after the glass tube shatters and the superheated hydrogen combines with the oxygen in the air.
So you get a regular explosion after the super explosion.
Yeah.
So that's think about it. Do you get something like that often? No, nukes.
I told a friend of this idea, and he said, "Oh, okay. Well, then in a few weeks I see a mushroom cloud there." But I don't think that would happen. It's not enough gas, right?
I know.
Yeah,
the cores will not touch. They will not have fusion or fission or anything like this. Because it's hot gas in the end, or ionized, whatever. But the pressure will not be maintained by the vessel. So this is too difficult to get the cores close to each other.
And also, ballpark numbers to get fusion type events going, you need about 1 million times the energy density of TNT. So I think you're still a few orders of magnitude off fusion.
Okay, that's good.
But there's an easy way to get around this. No, there isn't. You need less gas in there.
You could do some sort of magnetic confinement, like take one of the leads and wrap it around the tube so that as the current flows through it, it will sort of constrict the plasma down.
And can you not have like a circuitry where it goes like a swing where the charge goes from one end to the other, and you have a very precisely timed switch, and so you do not only get one discharge, but it bounces like a couple of hundred of times in a very short time.
Well, it will bounce a few times until the plasma dissipates. But as far as circuitry goes, I mean, I'm guessing he's going to be having discharges on the order of like 10,000 amps or something, and that is rather difficult to switch in the timescales we're talking about, and especially with these kind of voltages.
Yeah, so I guess if you wanted to buy a switch that is able to do this, you would quickly end up on some list for controlled parts for the Iranian nuclear program or something like this. Because
I think it would be like unobtainium, basically.
Yeah. Okay.
A friend measured the pulse current of one of the big capacitors, and it was above 80 kiloamps.
Yeah.
80 kiloamps was the point where the device said, "Nope, I don't want this anymore."
What device? Like the wire broke or the? Device. Okay, so you saturated your current transformer.
The device said, "Nope, too much power. I turn off. Gets too hot in here."
So, Phil, about your question with the water boiling, Is it called cavitation when the small bubbles collapse, or is it only called cavitation when it's a propeller or something on a submarine?
I don't know, but that's what it is, and that's why kettles make more noise. That I've got. So I've got this. I spent most of the day doing a high-speed video of water boiling, and it's absolutely super. That when they're actually relatively cold, you get very rapid cavitation and very rapid closing, which makes quite a lot of noise. Right? The reason, of course, for that is when you get the boiling, there is actually a higher pressure in there because the bubble is on the base plate of the kettle, which is providing lots of heat. And if you've got a thin film of water on there, it can actually provide the pressure to create an expanding bubble. Unless that goes into cold water, it collapses again. However, as you approach boiling temperature, it takes longer to condense the water on the side, so the bubbles get progressively bigger and bigger until obviously at boiling. The vapor pressure in those bubbles is atmospheric pressure, because that was one that always bugged me, right? Is the vapor pressure doesn't depend on what other gases you've got there. So the vapor pressure of water doesn't depend on atmospheric pressure. So looked at like that, why should it affect boiling temperature if it doesn't affect partial pressures? And the answer is very simple. You've got a steam bubble, and you've essentially got a pressure pushing down. And if your pressure pushing down is high enough to collapse the bubbles, then right. But the thing is that the bubbles that you got a pure steam, and the atmospheric pressure, it can be anything. So you actually do all these really quite fun things where you sort of suck on it and it starts to boil, and blow on it and it stops. I had an interesting day with a kettle.
Yeah, but you did not use your mouth to suck on it, right?
Occasionally. So I got a vacuum pump and some other stuff, but it's actually a direct participation with your experiment can be quite fun. So
yeah, but water vapor is not something you want to breathe.
So I actually built a small kit about where. So my high discharge is about 40 watts, maybe. So I pass I don't know a few amps and a few volts through resistance wire to make a really baby kettle.
Okay.
So and then of course it's all in a nice sealed apparatus which you can suck or blow on, depending on, and you do it without burning your tongue or anything. So
yeah, we had an experiment at school where the teacher lit a candle and then he blew it out, and then he explained why you could not suck it out, and so a physical principle why blowing out is easy and sucking out is incredibly difficult. Yeah. I was like 16 years old and thought, okay, according to this principle, what he just explained, it should be possible. I don't know the specifics, it's too long ago, but it should be possible if you make a paper tube and focus the point where my sucking happens really down to a precise point and went to the base of the flame where all the gas is and suck that away from the flame. It should work. I could be able to suck it out. And then I explained to the teacher that I think this could be possible. And then the teacher said he will not suck at the flame of a candle. And then I said, okay, when he is not courageous enough, I think the
youth will do what age is.
Then I volunteer. And then he said, yeah, I would just wanted to ask you, because I used that quite an unpleasant word. I used feige, and he was a little bit pissed. And then so I had to redeem myself and come down there and demonstrate. So what I did is I rolled up a piece of paper. I made the end a little bit wet so it would not burn immediately from the heat of the flame. Went really close to the flame and tried to suck out the flame. Cannot recommend, because what happened is the gas, the paraffin gas, got sucked through my piece of paper and then condensed inside my mouth.
Yeah, it's disgusting.
I mean the wax, the candle wax, the paraffin condensing in the mouth and a little bit down the throat, and I hope most of it until there and not actually in the lungs.
In the lungs.
Very unpleasant feeling. And the candle was still burning, so my theory was wrong as well. So, and that's what I thought about when you thought about sucking on a tea kettle. I thought, oh, not a good idea.
I would
Although-
have made a gas washing bottle for this, so I would have bothered.
A longer tube would be enough. So if I had a longer tube so that it had more room to condense the air before it hit me, then perfectly fine. But I had to improvise, yeah.
I've got a more cheaty version. It's called a dustbuster.
Yeah.
You know, vacuum cleaner of some sort.
Oh,
Yeah, but mechanical, yeah, of course.
It's cheating, I know.
And on other occasions, same teacher, we synthesized a lot of aroma, so the artificial aroma, like strawberry and whatnot, pineapple. And I think one of pineapple, they all use the different, some of the different organic acids as base of the reaction to synthesize that aroma. And the acid that was used for pineapple was buttersäure, so butric acid, the one with the really smell, with the really hard smell. And
the one that smells like bath.
Yeah. And then the teacher said he would not do that synthesis because he does not want to handle the smelly stuff. And then again spoke up, which ended that I had to do the experiment. But this time everything went wrong. I poured it into and everything went fine, and nobody left thinking like a raccoon.
You could theoretically get buttersäure from the fruits of the ginkgo.
Okay.
But the most ginkgos you find are male. Because, well, the female ginkgo produces fruits that are really bad smelling.
So people chop them down, right?
Yeah. But I know one place in my city where a female ginkgo grows. So I could go to pick some up in summer. I
Today I
could.
buy chemicals. If I want to do stuff with chemicals, I'm luckily in the situation that I can just buy everything now. When we were kids, then we had to synthesize a lot of stuff ourselves, so to look for dubious sources, but now I just buy everything.
Buying chemicals in Germany is not that easy.
So this is what gets me, right? When I last went back to England, or a few years ago, I went on eBay and you could buy like half a kilo of sodium just off eBay, no problem. And it's like, what? You know, for my entire youth, I had to sort of beg, borrow, steal to get any chemicals whatsoever. And anything even remotely dangerous was almost impossible to get your hands on. Now you can just order basically almost anything over eBay. The one thing that you can't do, though, and this one winds that, if I ever had an axe to grind against the EU, is the fact you can't buy mercury anywhere. Right? You go to America, you can buy 5 kilos of it, just no problem. Right? In Europe, it's harder to get a hold of than sodium.
Well,
So in the end, I had to order it through the institute. So it's the chemical suppliers, they're the people who sell the stuff. It's not particularly expensive. It's not actually that much more toxic than a load of other stuff. It's just there's like crazy regulations about it. So
Yeah.
I once accidentally bought 50 milligrams of mercury nitrate on eBay. Yeah, I took aluminium and converted it to mercury metal, so it's not that toxic anymore. Because I don't want this to be laying around anywhere near.
soluble mercury is much nastier than the liquid stuff.
Oh, organic mercury is much worse than this.
Yeah. But I mean, why is it that the rules are so tight around mercury? It's toxic, but it's not crazy toxic. I mean,
That's Europe.
Just public perception, right?
Yeah, absolutely.
They don't know it. They fear it. They prohibit it.
Yeah.
That's
The European
Europe.
continent is fertilizing mainly with ammonium nitrate. So if you go to like a Raiffeisen Agrarhandel, this is basically a supply for fertilizer in large quantities for companies in the agrarian sector. Then you can buy this in 50-kilogram bags and like a ton or so without problem. And
I tried it. It doesn't work.
Yes, you can. If you have
They don't.
if you're
give
if
you
you're a
this.
farmer, you need a license.
Yeah, you have to have a legit
then-
business, and then you can buy. Or you have to know someone with a legit business, and then just ask him for 100 kilos, and then he would just give you 100 kilos. So ammonium nitrate is absolutely no problem in Germany, and in the end you can steal it. So if you really want to make something bad with it, then you can just go to a remote farm and during the right time and open their thing and steal it.
But
in
when
Great
you get
Britain-
it yourself, when someone tries to blow up something like a cigarette machine
yeah, they
in
don't do that with ammonium nitrate.
in your city,
Yeah,
then the police stands in front of your door.
yeah, no. And
That's
it's
good.
very impractical to blow up secret machines and cash machines and something. I will not go into details on this because this is broadcasting live. I think we don't want to train terrorists. So in Great Britain, there is no ammonium nitrate on the market, not at all, because you had the problem with the Irish Republican Army and domestic terrorism for quite a while. So I think even in the 70s, they banned it, and the farmers in Great Britain have to use something else. they
use ammonium, right? But they changed the way they processed it as well. They make right. So for the bombs, you're going to get it really fine, powder, and the stuff is actually made as pellets, and they deliberately put water in it. It's still crystalline, but there's enough water in it that it's not really.
The stuff in Germany is also like very crude, and you have to do certain steps in order to make a bomb of it. But when I read up, last time I read up on it, then it's not available in Great Britain at all, because like the intermediate steps in manufacturing, or even if you mix it with a lot of other stuff, so that it loses its, it does not explode anymore if you mix it, for example, with Harnstoff. What the English word for Harnstoff is some other fertilizer, 50-50, then it will no longer explode. Not a chance.
But they tried to stabilize it with ammonium sulfate, but there was one big accident in Germany before the war.
No, I think shortly after the war, 18 or 19 or something like this.
Yeah, about 5 tons of this exploded.
Hundreds.
It makes a mess. They really explode. I mean,
the thing that was it clumps up. It grabs water from the air and it clumps. So they try to
hit it with hammers. Yeah.
No, not hammers.
Break it up.
The hammers don't do anything.
They used explosive to break it up.
An even better idea. I don't know why I didn't think of that. It's,
and 4,500 tons went off. It was the Oppau explosion in 1921. I will link the article here. 4,500 tons.
It was gigantic hole.
I mean, it really is the genius idea of looking for a gas leak with a match.
And they did not know that it was an explosive. So the people handling it did not really consider it an explosive when they did this.
I can imagine now, the guy sort of setting the explosives and his co-worker. You sure that's safe? Like you've read the safety regulations on this, right?
Yeah, they tried it. They made this a few times before and it didn't blow up. But
that's right. It's pretty erratic stuff.
Yeah.
The one time it blew up. So.
Yes, and I can imagine all the guy who died must have felt pretty hard done by. We did it loads of times before and it never exploded.
No, I think nobody of the guys involved.
It wasn't just one guy that died.
Yeah.
Really?
Everyone that was in a kilometer range or so was was dead. So I don't think any of the cables to set off the explosions was long enough so that any one of those survived. Actually.
So
It
it's
messed up the whole city nearby, and it was heard in Munich, the blast.
there's a famous. It's after World War II. It's one of the worst disasters in America. They had a ship full of ammonium nitrate. 2 ships.
Not just ammonium nitrate. I think blasting gelatin was there too.
No. They were just fertilizer ships. It was a limited ship, and it caught fire. And the firefighters came to put it out, and of course, all the people came along and started watching it because there's a ship on fire in the dock. And of course, 3,000 tons of ammonium nitrate blew up and killed everyone there, and it killed, I don't know, I think it's 400 people or something.
Yeah.
This reminds me of Tianjin, where the storing hall exploded there. The extremely massive blast.
That was the one in China about a year ago, wasn't it?
Yeah.
And we had an incident in Greece, I think 3 or 4 years ago. There was a ship with 650 tons of ammonium nitrate, and this was not used as a fertilizer. This was ammonium nitrate used for industrial demolitions. So they also had loaded all the accessories, blasting caps, all the fun stuff to make it actually go boom. And what happened is the company running the ship went bankrupt. The ship was in the harbor. The crew left the ship. No one was guarding the ship, and it was sitting like this in Athens harbor for like 4 weeks or so until the officials decided, we have this suspicious ship here lying around for like 4 weeks. Let's check on it. And then they found what they have there. And the first thing is what they did, they just drove it like 5 miles into the open and put it on anchor there until they figured out how to responsibly deal with the stuff. Yeah. Very, very interesting situation, to put it that way. Yeah. If any terrorists or some bad guys figured out before the harbor authorities, they would just have had a heyday blowing up Athens harbor. Yeah.
So just the one I was talking about was the Texas City disaster, and the interesting thing about it is after the first one blew up, a second ship with ammonium nitrate caught fire. And but it's quite impressive. Just take a look at some of the pictures of this, because it really does look like the whole city's been nuked.
Yeah, the parking lot picture on Wikipedia, 400 meters away, with all the burned out cars. Yeah.
I mean that's the impressive one is all the burnt out cars in the lot. I mean, whatever happened there was big. It killed 580 people, which, and also, I mean, the ship that blew up there's nothing left of it. It's, they sort of found parts of the hull, but basically.
The photo says the large piece of wreckage in the foreground may be for the Grand Camp. So this is a large piece, like a few meters, and they're not even able to identify if it was from the ship or not. Yeah.
Yeah, I mean, I remember when I was a kid blowing up a Coke can with an M80, and then that made a mess of it. But 2,000 tons? Yeah. How many tons was it? Approximately 2,000 tons, 2 kilotons. Yeah, so I mean, you're getting into the nuke region. I mean, nukes. The Hiroshima nuke was what, 20 kilotons, and this is 2 kilotons.
Yeah, they did a few large conventional explosives for nuclear testings. In order to compare a large conventional explosion to an explosion, they set up ammonium nitrate fuel mixes in nuclear test sites, and I think the biggest one of those,
Sailor Hat, Operation Sailor Hat, 0.5 kiloton.
There was one, Operation Snowball and Operation Sailor Hat, with 3 times 500 short tons, so 450 tons 3 times, but there was also one that was called minor scale, and this was 4,744 tons. Set off in White Sands missile range in 1985, so quite late. Probably they're using that data until today for computer models and stuff.
Got a benchmark in nukes somehow.
Yeah. The names are quite interesting. One name is Distant Image, and this is precisely the way I would like to image it from a distance.
Yeah.
Much worse is ammonium perchlorate, because it can act as a fuel for. It is an oxidizer, but it can act as a fuel.
Oh, it'll explode on its own. Yeah, I mean it's vicious stuff. It's used in the shuttle, the space shuttle solid rocket boosters, and there was a big explosion with that as well. So after the Challenger disaster, they started stockpiling ammonium perchlorate in this place in the desert whose name I've forgotten.
Pepcon was.
Pepcon. There we go. There we go. Yeah.
I recently learned about chlorine trifluoride. Very, very potent oxidizer, and the Germans were actually crazy enough to experiment with it as a rocket fuel during World War II.
Really?
Yep.
Ammonium? What?
No, not ammonium. I will package it. Chlorine trifluoride.
Oh yeah, I know it. Yeah, I know it.
One chlorine atom and 3 fluor of fluorine atoms. This thing sets solid bricks on fire at minus 200 degrees Celsius or something like this. So super reactive, super oxidizing. And the only way to store it is in steel containers that have had fluorine gas inside them for quite some time, because then the inner of the steel is already reacted and has already some steel fluorine compound. Yeah. And then the other one cannot react. But then if you put pressure on the steel and it gets some small cracks inside or some, then it will burn the steel and everything will go up. And I think this is one of the strongest.
Yeah, basically it's fluorine gas with a higher boiling point. That's all it is. It's fluorine gas. But the only reason you make this compound out of it is this is the chlorine trifluoride, I think, is almost liquid at room temperature.
Yeah, it may be. Yeah, but it's stronger. The chlorine helps in oxidizing, so it is a stronger oxidizer than the fluorine by itself, from what I heard. The same for like this chemical.
As far as I read, it was so reactive that the Germans thought, nope, we better don't do something with this.
Yeah, and the problem is also all the what is the name? All the acid, this flesh-eating acid you get.
Hydrogen fluoride.
Yeah, exactly. Yeah. When you actually burn larger quantities of this stuff, so it would be not very nice to the ground crew of a rocket launch to maybe in stoichiometric, not optimal ratio, burning it, and then you have like a lot of the stuff flying around in the air.
Well, yeah.
Have you heard about this extremely powerful laser China is building?
Not directly.
They are building a laser that has that's so strong that it they say it could rip space and time apart, because it reaches what it's called. It's a critical energy density. I don't know the name.
I'm not so sure I know what it is anyway. So.
Yeah, I'm interested in the lasers they will put on the aircraft carriers in like 10 years from now, because the next class of American aircraft carriers has so powerful nuclear reactors that, from what is currently known about the consumption of electric energy, it only accounts for like 50% of the budget they have on the aircraft carriers. So they speculate that the other 50% are planned to be used in an upgrade pack, either for railguns or something like this. So
Railguns is possible. I don't think lasers
or
are much
laser
used.
system, or both. Yeah.
Pyro made a video about this critical energy density with lasers. And the laser that China is building, when they turn it up, it's over this energy density
threshold. Yeah.
Yeah.
Well, I mean, there's a few of these free. There's a few of these free electron lasers around, but I'm not so sure. I've never really come across this sort of critical energy density that you're talking about. But so I've got no idea. I've never read anything about it. I'm complete virgin on that.
Yeah, there are some. I could imagine what there are some energies where like conventional physics stop working really. So when the temperature is so high that you cannot model the like the vibration of the modules anymore because they would approach light speed or something like this, or so like a theoretical maximum on temperature. There are quite a few because some physical models then do no longer apply and you need a different model. And I would go so far in saying it will rip space-time apart because we have neutron beams, we have stars, and we have other astrophysicist phenomena in the sky, and they have more energies and higher densities than what we can.
That being said, yeah, I remember some years ago, sort of when I was a kid, sort of speculating that what if they got it all wrong about those supernovas? Those supernovas aren't stars exploding. Those are people who have finally reached this sort of level of technology where they can do something that can't be done elsewhere in the universe, and make a miscalculation.
And actually, if we could detect really cold temperatures over a very large distance, then this would be the perfect way to detect other civilizations. We can't, of course, because cold is not radiating, because the coldest place in the known universe is in a lab in, I think, the USA or in Germany, because we humans were able to cool something down that cannot be observed during with natural processes. Also, the plutonium in our atmosphere will immediately give away that some life form was thinking around with nuclear power when the aliens will visit us, because no way to account for those quantities of plutonium by a geologic or astrophysical process in our solar system.
Okay, guys, I think it's maybe time to wrap it up. It's getting on.
I can't find the video right now.
Yeah, text is always better than video. Next time, take a few notes, bring text. Text is so much more better.
And I'll take a look into it also. I mean, the critical energy density that's going to rip space and time. It can't be that difficult to find on the internet.
And if they have a Kickstarter about it, then Phil has something to debunk probably, because it sounds a little bit like pitching.
I think if I made the model of the micro hyperloop, I could start a Kickstarter to make mass produce them and sell them.
I've got it. No, you're going to make a hyperloop for mice or something.
Yeah.
Actually, no, that's the thing. So no one's ever transported anything living in the Hyperloop. mainly because, if anything goes wrong, it's a pretty ugly.
Yeah. I think I installed
in the Hyperloop. No one can hear you scream.
I think I install a valve somewhere at the track, so when it passes by, I can open the valve and and you can see what happens with the with the thing.
Yeah. There's a lot of energy in a vacuum.
But until then, there's a lot of programming. I will use a microprocessor, a PIC, and the only way I can program a PIC is by assembler. I want to make the levitation with the PIC and the acceleration.
Yeah.
This could take some time until I got this.
I was about to say linear induction motors, they're in principle simple on paper. In practice, trickier.
When you want to program them, it's not that easy. I made a program for a motor controller, but I didn't test it yet.
Yeah, and do the following, do yourself a favor. Write a prototype, simulate it a little bit, and use the programming language that is not a pain. And then when you have it all working, then start with the assembler, because then you have a very easier time fixing bugs, tweaking your algorithm, going into simulation. So if you have the means of doing it a little bit like this, then I would recommend in favor. If you don't, then at least do a lot of stuff with pen and paper and like on math, improving what your control feedback loop is and how it is supposed to work before actually doing it in assembler.
For the control and feedback loop, I want to use these chips that are TL494.
Oh.
These are used for switch mode power supplies. They have 2 error amplifiers, and I could use them to so they turn on when the threshold is reached, and they turn off if it's under the threshold. And if I use these, okay, they don't lie there anymore. The Hall effect sensors, I could theoretically levitate something with these alone, and then I only have to with the PIC I only have to turn the the ones off one at a time, so I get a slope.
Okay.
Sounds interesting.
Yeah.
Good luck.
Thank you.
Okay, guys. It's good hanging out with you all. And yeah, hopefully next month. Right.
Yeah.
So this month is an absolute nightmare for me. I'm in a reactor next week. The week after that, I'm in a synchrotron. God knows where I'm going to get stuff done. But anyway, next month. Look forward to it.
I were at the